Hello, I hope each and everybody out there, those are watching this video, are doing great and having good health by the grace of Almighty. In this video, I'm going to explain you that some sort of problem solving techniques in case of Archimedes law, and this is a very important. Student of English versions, O levels and also Cadet college, you know that this type of questions, though from my side this is very primary level type of questions, but there are some sort of critical types of questions also that we need to solve, and we need to understand that how to think about solving these questions, though it's very specific part that Archimedes law, which was actually explained under the chapter 5, pressure and state of matter. So in this chapter there are three laws which is very important. You know that Archimedes law, Pascal's law and Hooke's law. I shall be uploading three type of videos regarding these three type of principles, and in this video I am trying to give you some sort of idea. These two questions have been selected, that how to solve it. And of course you need to understand the concept of Archimedes law, and also you need to know what are the principles of this chapter. So now you think, this is number 1 and this is number 2. I should start from number 2. Why? Because it's relatively easier, and those students are doing this type of mathematics first time. I think you should start from the primary level, and then when you understand these things well, then you go into the critical level or advanced level. Think about it. Before going to explain, I'm just giving you one thing, that you know what are the principles of this chapter. As you know that at first we know that from the definition of density, that is rho equal m by v. You know it. And then second is that you know the buoyancy. When we do some mathematical problems regarding buoyancy, the equation is buoyancy equal v rho g. So the buoyancy is one type of F which is equal to v rho g, and we need to use these things in this type of problem solving questions. Think what is written, the weight of an object. So whatever the object is, and of course one thing is important, you know that what is the Archimedes law? If any object is submerged into water, then it will definitely lose some weight, and that lost weight is equal to the upthrust or the buoyancy or the amount of water displaced by the object. That is very important. So when it is submerged into the liquid, that liquid can be anything. That liquid can be water, that liquid can be kerosene and whatever. We need to know the density of the liquid. We need to know the volume of the object. We need to know the mass of the object. And then we will definitely be successful to solve this type of questions. Let's see what's given. The weight of an object in air. So in air is 19.6 Newton, and in water it's 15.68 Newton. So we can see that the weight of the object is greater than water, and we know that because definitely when it is submerged into the water, it will have an upthrust or buoyancy. For that it will definitely lose some weight. And then the question is, coming up the questions, another thing is that the volume of the object is given 400 cm cube. So another thing is that when in a question paper the unit is given as a cm cube or centimeter cube, we need to convert it into meter cube, because we need to solve these questions as MKS styles or SI unit. The question is, how many times the density is greater than the density of water? I just wrote a small keywords, but the question is that how many times the density of the object is greater than the water, and also is it following the Archimedes principle. So it has two questions. Okay, so now let's see what's given. So in this data, what is given? The density, the weight the weight at air. So you know that the object weight at air is given 19.6 Newton, and of that object weight in water is given 15.68 Newton. So two type of weight is given, and of course the volume is also given 400 cm cube. Now we need to convert it into meter cube. How? Because whenever we need to convert it, we need to do it 400 times 10 to the power minus 6, and then it will be meter cube. How? You see this here, suppose 1 cm cube. If I try to do it in meter cube, what will be the amount? So in 1 cm cube it means 3 times I have to multiply 3 times, and then it will be centimeter cube. Now if I want to make it meter, then each time I have to divide it by 100, then it will be meter. Each time I have to divide it by 100, then it would be meter. Now I got 3 meters. Okay? Now I got 3 meter, and then what is the actual calculations? You see that here 1 by 100, 1 by 100, 1 by 100, then 3 meter. Now you think about it. 1, 0, 0, 0, 0 and 0, 0. So we got 6 zeros upon 1 and meter cube. And it is actually what? 10 to the power 6 meter cube. What is actually 10 to the power minus 6 meter cube. So we can say that 1 cm cube is 10 to the power minus 6 meter cube. So that whenever you got any cm cube, we can definitely multiply by 10 to the power minus 6. Okay? So that it would be definitely turned into meter cube. So we got it from centimeter cube to meter cube. I hope you understand this process. And this is very simple. This is very, very simple. And now, if you think the air is 400, so we can say it as it is 2 zeros, so we can make it like 4 times 10 to the power 2 times 10 to the power 6 meter cube. Now these things, so we can say 4 into 10 to the power minus 4 meter cube, which is same. So you got V, we got weight in air and also weight in water. Now the question is how many times the density is greater. Now we need to find out the density, and to find out density we need to know that rho is equal m by v. So we got v here, but we don't know what is the mass of the object. And to find out mass, what we need to know? We need to know the weight of the object. Weight of the object. So weight of the object is given. This is given, that is air. So if I need to know the density, so it's given that 19.6 Newton. So we know that weight is equal mg. So we know that m would be w divided by g. Now we can say that 19.6 by 9.8, it's actually 2 kilogram. So we have 2 kilogram, and you see that this object, the mass of the object is 2 kilogram, because the weight of an object in air is given. So we got the mass, and now as we got the mass, we can get the V, that m is 2 kilogram and V is 4 times 10 to the power minus 4, and then it would be kg per meter cube. Now we can see that what is the answer. So if I divide 2 divided by 4 times 10 to the power minus 4, that is 5,000 kg per meter cube. So the question is how many times the density is greater than the water. So as we know how many times, I mean if I know that the density of water is 1000 kg per meter cube, then we can say that the rho of object and the rho of water is actually 5000 divided by 1000 is 5. So the density of this object is 5 times greater than water. and I hope this is easy. And of course, those who are watching these videos and tutorial, this is something very easy, and of course we will do some advanced level of mathematics later on, but before going to jump on that level, you must ensure that you understand this process, though it's very easy. And now the second question is that is it following the Archimedes law? And how we will do it? How we will do it? Okay, let it immersed and then see. What we got? We got V, right? We got V of the object, which is 4 times 10 to the power minus 4 meter cube. We got it, V. And we also got the M, which is 2 kilogram. So till now we got this V, W and M. And now the question is, when it was immersed into the water, we see that it lost some weight. So what is the lost weight? The lost weight is the weight of air minus weight of water. So we can see that 19.6 minus 15.68, this amount of Newton it lost. So if you divide 19.6 minus 15.68, which is 3.92 Newton, so 3.92 Newton, this amount of weight it lost when it was immersed into the water. And now we need to think that what is the buoyancy that it felt. So find out the buoyancy, what to do. So buoyancy is V rho G from it. We know it, V rho G. So now you think the V is this 4 into 10 to the power minus 4. Rho is the liquid where it was immersed, and that is actually water. And we know the density of water is 1000, and then times 9.8. So what will be the answer? So if I divide 4 times 10 to the power minus 4 times 1000 times 9.8, and this is, yes, this is same, 3.92 Newton. So from the data we can say yes, it follows the Archimedes law. Simple. We just finding that the lost weight according to the data is equal to the amount, the upthrust or the buoyancy it felt when it was immersed into the water, because this V is not the volume of liquid. This V is the volume of the object, and this rho is the density of the liquid. If this object was immersed into the kerosene, then we need to think about this rho should be 800, not 1000. This is not the density of object. This is very, very important. When you will do these sort of things, you must remember one thing, that V is the object volume and this rho is the density of the liquid when it was immersed. And this G is always, similar, that 9.8 meter per second square. I think it's easy. Okay, so let's jump to the next part. So if you see the first questions, and it's given something like, okay, similar test, but you see the area and the height of a rectangular object. So the rectangular object is given. So what is given? The given data is the area is given, which is in centimeter square. So if it is given as centimeter square, we need to make it in meter square. And in this case, what we need to do? We need to do as 10 to the power minus 4, yes, meter square. And also see, this is centimeter is also given. The height is given 3 centimeter. It should be 0.03 meter. We definitely think about the data and the unit is given in the question paper. Otherwise, we won't make it possible. Like 24 centimeters square, we need to make it meter square, and then it should be in meter. So we got area and height. So when you got the area and height, we must find out the volume. So the volume is actually area times height. So you got 24 times 10 to the power minus 3, minus 4 times 0.03. Now you can see what should be the volume of this. So it will be like 24 times 24 into 10 to the power minus 4 into 0.03 is 7.2 into 10 to the power minus 5. 7.2 10 to the power minus 5 meter cube. We got volume. Okay. So the weight of the object is 1.4 Newton when it is immersed in kerosene. Well, then is a new liquid. That when it was immersed into the kerosene, that means the weight of the object in kerosene was 1.4 Newton. It means it was actually, when it was immersed into the kerosene, it is not the actual weight of the object because it is not in air. It means this value is actually considering the buoyancy. And the question is, okay, when the density of kerosene is given 800 kg per meter cube. Okay, now what to do? The question is density of the object. Again, you think about it, the density of the object we need to find out m by v. Okay, and now we see that we have v, we just got v, we have v, but we don't have m, and to get m we need to find the weight. And how to get the weight? We know that it was actually lost. 1.4 Newton was lost. Now if we got the buoyancy that how much it lost, then we got the buoyancy. See, the V is 7.2 times 10 to the power minus 5, and this rho is 800 and this G is 9.8. So we got times 800 times 9.8, which is actually 0.56 Newton. So this Newton was lost. So we need to find out the weight of that object in air. So as we need to find it out, that weight in kerosene should be equal to the buoyancy, this one. So we know that 1.4 Newton plus 0.56 Newton would be the total weight of the object. So we got it, 1.96 Newton is the weight of the object in air. And now you think this W equal mg. So this m was the questions, like rho equal m by v. So we need to find m. So to get m, we need to see that m is equal w by g. So the weight we got is 1.96 Newton divided by 9.8 meter per second square, that is 2 kilogram. Again we got that, oh no, it should not be like that. It should be, I think, 1.96 divided by 1.96 divided by 9.8 should be something 0.2, sorry. So it is 0.2 Newton kg. So 0.2 kilogram is the mass of the object. Now the question is the density. So now we can find out the density, and when to do it, okay, then I think it's not required. Okay, so the question is rho equal m by v. As we got m 0.2 and the v is 7.2 times 10 to the power minus 5, then it would be like 0.2 divided by 7.2 times 10 to the power minus 5 is 2777.7. Wow, a lot of 7. 2777, right? Yes, 0.78 kg per meter cube is the answer. Is the answer. Well, it took some steps to get it, and that is why I am doing it. And those who are watching this video, please think then when you will try to find out the data what is asked, you need to know what is the concept. And in this data, what was the question? The question is to get density. So you can think what was asked into the questions. So you know that you have to find the density. So to find density, the equation is rho equal m by v. So from the data, you got v. Okay, so now you need to find m, that means the mass of the object. To find it out, what is the process? What is the data you have in your hand? So you got buoyancy, and from that you got that this buoyancy is the lost weight. Then you add, you got the weight of the object in air, and then from that purpose you got m, and that m was used to get rho. So that is very easy. And you think the steps was like 1, 2, 3 and 4. So these following 4 steps you must require to find it the density of the object in this data. And this type of similar question you will get if you just solve the test paper, or even you got some sort of practice, you'll definitely have it. Next question, same question, does it follow the Archimedes law? And now what to do? Now I think it's already here. How to get it? How to get it? Then is it following, I mean these data, is it following the Archimedes law? So now we need to find the lost buoyancy. This buoyancy is 0.56 Newton, right? This is the buoyancy, then it fell. So now we got, see, we got weight in air, and now you see we also get weight in the object in kerosene. You see 1.4 Newton. Now you think one simple thing, it's just take, it's given here also, that is it following the Archimedes law? Yes, of course it's following the Archimedes law. How come I know that? You see the buoyancy is 0.56 Newton. You got earlier 1.96 Newton is the weight of this object in air, and 1.4 Newton is given what is the weight in kerosene. If you just minus it, then you will get 0.56 Newton. That means when this object was merged into the kerosene, it lost this amount of weight, and which is equal to the buoyancy. So it definitely follows the Archimedes law, and I hope you understand. You please see, and of course after watching this video, let me know that do you really solve it with your own hand, and you solve some more problems following your test paper or whatever your source you have. Plus let me know that do you really understand that what I explained here. I just pick some easiest type of or primary level type of Archimedes law mathematical problem. I'm coming up with some critical type of things where multiple steps is required. So I think this is the questions and this is the answer. And if you got any some sort of like new process of doing these calculations, do let me know. And of course, if I make any mistake in the whole time of my uploading class, please sing it in a beautiful way and let me know what is the mistake. So take care, see you in the next class with the mathematical problem of Pascal's law, and also I'm coming up with some sort of like Hooke's law. So take care, stay well.